Good morning, afternoon to you all, and welcome to the periodic table. Today we are going into downtown to greet some of its known residents. Let's hail a cab to get into downtown. Here comes one now. And here we have our first element, Francium. He's quite the burly fellow with an atomic radius of 348 picometers. He has one of the largest atoms in the periodic table. Too bad he's the second most rarest element, and it can take up to several $billion to extract him, never mind even find him. Francium is radioactive, and his short half-life of 22 minutes relegates him to being only used for research purposes. Oh, Jesus! We just met fluorine. He's one of the most electronegative elements in the periodic table, and he also has a very high ionization energy to keep those electrons to himself. You can find this little man in rock, coal, and clay commonly, as he is the 13th most abundant element. They can be used in toothpaste or in some very acidic acids. This guy may seem a little greedy, but it doesn't mean to hurt anyone, as he is not radioactive. If there's one thing you would first notice in this city, is its high abundance of hydrogen. These guys make up most of the known universe. To find them on Earth, you can find them mostly in water. They are most prominently known for their use in rocket fuel and in the hidden thereto deadly effect. Whoa! Did you see that? That was Boreum. We don't know a lot about these people because they only have a half-life of under 1 minute. You can't find these guys outside nature, as they are mostly man-made. We have finally made it to downtown, also known as the S block. Over there we can see a sodium atom waiting for their cab. Sodium can light on fire if exposed to water. However, it's rare to see a pure piece of sodium out here, as they are mostly found combined with other elements in nature. But they are the sixth most abundant element in the Earth's crust. You can usually find them being used in nuclear coolants or your average table salt. We must be in Chinatown, as China owns up to 75% of all the world's tungsten. Tungsten also has a higher melting point than the temperature of lava. Again, it is also rare to find free tungsten, as it is always combined with other elements in nature, so the costs of finding it range from $25 to $2,500. They can be used in light bulbs or to strengthen alloys like steel.
Get out of my house.
Looks like we've made it to the quieter town of the F-block elements. Over there we can already see Uranium relaxing on his porch. It's not rare to find these, as they are as rare as zinc or tin, but it costs $22 million to find it and mine it.
Back in 45, me and my pals were crammed into a compartment of some sort. Then we felt a sharp jerk and started falling somewhere. For a while we couldn't see anything, so everything was white. It cleared and most of us were here save for a few. We were surrounded by destruction, and by God, it was horrifying.
That's right. Uranium can be used for nuclear bombs or in nuclear reactors to provide power for cities. Oh hey little guy, it's very rare to find plutonium out in nature. They can usually be found in uranium deposits, but they could also be man-made. It can cost up to $8 million to make a kilogram of plutonium, but they are usually used in nuclear bombs and fuel. Well, that should wrap up our visit to the periodic table, and we hope you all enjoyed it.